Hello! So, our problem is this one. Bats are cast-lab caverns, leave the cave at dusk in search of food. When they return at dawn, they fly over the cliff face that supports the cave entrance. They fold their arms and legs, then plummet like rocks until a few meters above the floor of the cave entrance, where they spread out the skin of membranes between their arms and legs and pull out of the dive. Assuming they drop from a height of 100 meters and do not open their legs or wings until they are 3 meters above the floor. Okay, so we need to use the UAM equations, also called kinematic equations, because they're telling us they plummet and fall like rocks. Our data for the first part is that y equals, and since we know velocity initially is 0, we're going to replace it in the equation, well, substitute it, and we know that it's going to cancel out, so our equation will be y is equal minus 9.8 meters over second squared over 2 times t squared plus 100 meters. This is going to be our position function. That's why we add the 100 meters. Now that we have our equations, we're going to pass to the point B. Point B asks, calculate the derivative of the function using the limit definition of derivative. So we have our function that is equal to y that is equal to minus 9.8 meters over second squared over 2 times time squared plus 100 meters. And again, that y is still the overside because we passed it. So it's not like we put it just to clear what equation we're using. First, we're going to talk about a bit about derivatives, and it's f prime x that represents the formula for the slope of the tangent line in case of a graph. And in this problem, it's going to be of our functions, and they're asking you that. I'm going to use this graph as an example just to clear up what the slope of that tangent is. The limit definition will be as the limit of h approaching 0 is equal to the function times x plus h minus the function over h. Before using the formula, we're going to find the function times x plus h. So we substitute our variables as that, in our case, with t plus h, of course. Now we can apply the formula. So our limit of h approaching 0 is equal to minus 9.8 meters over second squared over 2 times t plus h squared plus 100 minus our function all over h. Then we solve that binomial square there. And we find that when we multiply it, we can eliminate or take out most of the terms. And we're left with 2 times minus 9.8 meters over second squared times t times h minus 9.8 meters over second squared times h squared over 2 over h. And we can plug over 1 to make that division, multiplying the terms at the top times the last terms and the 2 in the middle. And then we're left with the very same terms of the top over 2h, and we cancel out 2 terms there. We can cancel out the 2 and the h. Then we substitute the h by a 0. We're left with f prime x equals minus 9.8 meters over second squared times t, and that is our derivative.
Ignoring air friction, how fast, that is, the magnitude of their velocity, are they moving by the time they pull out of the free fall?
To solve this problem, we need firstly the data, which is distance in the y direction is equal to minus 100 meters, minus because it's going downward, little g, which is equal to minus 9.8 meters per second square, and initial velocity, which is 0 meters per second. The formula to get the final velocity we want is 2 times little g times distance in the y direction, which is equal to final velocity square minus initial velocity square. To get to velocity final, we need to clear the formula, and that is by square rooting 2 times little g times distance in the y direction plus initial velocity. After we do this, we substitute, and final velocity is equal to square root of 2 times minus 9.8 times minus 100 plus 0, and that is the result of square root of 1960, and that results 44.2718 meters per second. If their vertical velocity essentially drops to 0 as they move from 3 meters to 1 meter above the floor, that is, during the time period in which they pull out of the free fall, what is their vertical pull-out acceleration? For this problem, we just want the acceleration, and for that we need the data. distance in the y direction is equal to minus 3 meters, initial velocity is equal to 44.27 meters per second, and final velocity is equal to 0 meters per second. The formula we need is 2 times acceleration times distance in the y direction equals final velocity square minus initial velocity square. To isolate the formula, we just want acceleration, so this is equal to velocity final square minus initial velocity square divided by 2 times distance in the y direction. And for this solution, we just need the substitution, which is 0 meters per second minus 44.27 meters per second divided by 2 times minus 3 meters. After that, we get minus 1,959.8329 meters per second divided by minus 6 meters, which is equal to 326.63 meters per second square.
Problem E. How long does it take them to execute their pull-out? So for this problem, we need to find the time. First, we break down the data, which is y equals to minus 3 meters, final velocity equals 0 meters over seconds, initial velocity equals 44.27 meters over seconds, acceleration equals 326.64 meters over seconds, and time we don't know. Then we continue with the formula. We're going to use acceleration is equal to final velocity minus initial velocity over time. When we clear this formula, we have that time equals final velocity minus initial velocity over acceleration. We substitute this and it gets us to time equals 0 meters over seconds minus 34.27 meters over seconds. The result of this is divided by 326.64 meters over seconds. We get then the result, that is time equals minus 44.27 meters over seconds divided by 326.64 meters over seconds. So then our result is that the time equals to 0.135 seconds. Question F. Draw a diagram that explains these actions. Okay, so first we have the cliff, and obviously at the bottom we have the ground. We have our bats falling in a free fall from the top of our cliff to the ground. The total height of the cliff is of 100 meters. The bats launch themselves in little balls with their arms and legs curled up together, but just when they are about to reach the ground at 3 meters, they extend both their wings and legs to stop from falling down and crashing into the ground. We have that our total time is of 0.13 seconds. Our initial velocity was of 44.27 meters over second. Our final velocity is equal to 0 meters over seconds because they stop, and our acceleration throughout the whole process is of 326.64 meters over second.